Okay, so now we're going to discuss number 2 and number 3 for your chapter 7 workbook structure questions. Because on Saturday I don't know what happened, but it seems that you've accidentally left the meeting, but the time is already over for the class, so I'll straight do that discussion for these two questions as your homework discussion lah. Okay, firstly, sulfuric acid is a strong acid and ethanoic acid is a weak acid. They tell you that this one, strong acid, ethanoic acid, weak acid. Actually, I already gave you the chemical formula for ethanoic acid. It's actually CH3COOH. Define the term acid, so you have to define. And okay, when defining, always write down the term first. Acid and then is, okay, it's easy, proton donor. Or you can write H plus donor. It's the same thing. Write an ionic equation of an ionized sulfuric acid. Okay. So we have to write the ionic equation for ionization or dissociation. Of sulfuric acid. So this one, given the chemical formula is H2SO4. Okay, this one, since it's 1 mark, so we don't have to write the state of the physical states of the substances lah, the reactants and products. So straight away 2, and then this one, H plus and okay, let's continue. Okay, so this one is because this one is after ionized, so they only produce 1 H plus ions, only take out 1 H plus only lah. So this one plus ma, so this one should be minus lah, to make it neutral over here lah. Okay, so this one is H, because only 1 H is taken out. So SO4 minus. This minus, let's move it nearer lah. Okay, what is two of the all of the hydrogen ion is already dissociated or ionized. This one we write it like that, H2SO4, and then since it's strong acid, so it's the arrow is one way, and then 2H plus SO4 2 minus. And then they ask for ionic equation for ionized ethanoic acid. So this one, ethanoic acid we already know ma, CH3COOH, and then two-way equation because it's reversible, because weak acid is they only ionizes partially. And then same thing, H plus. So after we take out the H, we still left all these things ma. So plus CH3COO, and then this one minus. So far should be okay for you lah. And then let's move on to D. Okay, state the differences between strong acid and weak acid. So this one, it's in the notes lah. Strong acid, they will, okay, let me write strong acid ionizes completely, or you can say dissociates in water to form large amount of hydrogen ions. And then weak acid ionizes partially in water to form only a small amount of H plus. So this one 1 mark for one difference lah. This one ionizes completely, while this one is ionizes partially. Must write in water and then to form large amount of H plus. This one forms small amount of H plus. Okay, this, let's see D. E. Describes the test shows sulfuric acid is a strong acid while ethanoic acid is a weak acid. So how can we prove it that H2SO4 or sulfuric acid is a strong acid or the other one is a weak acid? So this one, we can use a pH meter. Or we can use universal indicator also. Or the third way is to, this one is more or less related to the electrochemistry, chapter 4. So this one, we make a simple cell with a voltmeter. In other words, we make a voltaic cell. So I'll give you the okay. Or the fourth way, there's actually many ways. We use the chemical properties of the acid RBC. One of them to react. One of them is the reactive metal. So we use this acid to let them react with the metal. So let's write down the answer for the first one first. First method, pH meter or universal indicator. So this one you can say that first point is use pH meter or universal indicator. And then second point is you say that if the pH is 1 to 3, it is a strong acid. And then if the pH is pH 4 to 6, it is a weak acid. So same observation for universal indicator, but you have to write it in a different way. So if it turns red, it is a strong acid. If it turns orange or yellow, it is a weak acid. So this is the first way that you answer this question. Second way is to use the voltaic cell. So set up a simple cell with voltmeter or you can straight away say set up a voltaic cell. And then a weak acid shows a low voltage, while a strong acid shows a high voltage. Okay, so these are the first two ways to answer to test strong and weak acid. So the third way, I don't have enough space, so I think I have to rub off the first one lah. Okay, so this one, third one is the acids okay, add what metal can we use? We can use magnesium lah. Add magnesium stride. Magnesium we normally use ribbon into test tubes containing both the acids, and then the observation: a strong acid reacts vigorously. So you will see the reaction very fast lah. While a weak acid reacts less vigorously. Okay, so these are the few ways to answer these questions lah. Okay. F. When sulfuric acid is added to barium chloride. So barium chloride, we know that barium, if its ion is Ba2+, chloride is Cl-. So if we cross them together lah, they will form BaCl2. And then this one is H2SO4. Okay, there is a change observed. Describe the change and explain why. So this one, we can try to write down the equation. H2SO4 plus BaCl2. Acid, they will react with actually they will react with salts also. And then this one is, they will exchange partner lah. So this one, okay, H will be with Cl2, so this one is HCl and then plus BaSO4. And then to balance the equation, 2 hydrogen, 1, so this one multiply by 2, 2 Cl, 2 Cl, okay, SO4, SO4, so it's balanced. So this one, HCl will be a clear solution. But when you observe something, normally it's a precipitate or color change. Or residue form. Or color change. Okay, so this one, we have to describe the observation. So this one, Barium sulfate, this one is BaCl, not Cl4, SO4. This one, barium sulfate, is actually white in color lah, a white solid. So for solid, it will form as precipitate or residue. So this one we can write formation of white precipitate. Okay. Sulfate, this one, white precipitate, how to form? So this one I have to write the ionic equation for the formation of barium sulfate. So BaSO4. How to form? We have barium ions, so this one is Ba2 plus in aqueous state. They will combine with here. SO4 2 minus in aqueous state also, sulfate ion. Then they will form the BaSO4. So this one you have to say sulfate ions react with barium ions to form barium sulfate. Okay, so this is how you answer the question lah. Okay, number 2 is done, so now we have to move on to number 3. All bases can be neutralized by acids. And then they ask you to define base. Okay, so we already know base is proton acceptor. This is how you get 1 mark. B. When sodium hydroxide is tested with red litmus paper, it turns blue. So this one is in the indicator part already. And then they ask you to explain. Okay. Explain why. So this one, for litmus paper to turn blue, they have to detect, for the indicators to have effects, not effects, to react and then have the observation. They have to detect if there's the if base they have to detect OH minus hydroxide ions. For acid, this one is base. For acid, they will detect for H plus. So this one, if red litmus paper turns blue, means they already detect the OH minus the hydroxide ions. So this one, you can straight away say sodium hydroxide contains hydroxide ions. Just like that. Your second mark of the question. Okay. C. When sodium hydroxide and ammonia are tested with a pH meter, each of them has a pH of 14 and 11 respectively. Okay, so sodium hydroxide 14, ammonia 11. So this one, the pH is higher. This means that the concentration of OH minus in sodium hydroxide is larger compared to ammonia. And then we also know that this one is a strong alkali, since it can dissociate in water and form this much of OH minus. And then if like that, ammonia will be a weak acid. So state the difference between them. So one is strong acid, one is weak acid lah. So 4 marks, okay. This one. Sodium hydroxide is a strong acid, and then which ionizes completely in water, while ammonia is a weak acid which ionizes partially in water. Okay. This one you can still add to form large amount of hydroxide ions. This one to form small amount of hydroxide ions. Okay, and then after that we have to talk about the concentration of hydroxide ions. So the concentration of hydroxide ions for sodium hydroxide is higher than that in ammonia. So for this one, first point will be at strong acid and then ionizes completely in water. This one first point, second point, and then this one extra point from large amount of hydroxide ion, your third point. Weak acid, 4th point, ionizes partially in water, 5th point. From small amount of hydroxide ions, 6 points. Actually, this kind of question you can get more marks from the given points lah. And then concentration of hydroxide ions. Whenever you mention this, you will get 1 mark. And then you say that sodium hydroxide is higher than the other one. The other mark. So this one, 4 marks. Actually, you can get to up to 6 marks. Yeah. So because I just realized that these two, actually 1 mark. So 6 marks in total. Okay. Here. Sodium hydroxide is usually used in identifying cations. So we use this sodium hydroxide to identify cations. What is cations? Cations are positive ions. It is also used to identify anions. What are anions? Negative ions. Okay. What is the anion that can be identified using sodium hydroxide? And then this one, we will get 1 mark if we get the anion correct. And then describing the test, 2 marks. If this one wrong, this one will be wrong. So have to be careful. So this one, we can use this to test for actually nitrate ion. So this one is NO3 minus. This one, nitrate, we can actually test it like that. The procedure lah. First step is, but during exam we don't write the first step. This one is, I want to make it simple for you to revise. This one, we add sodium hydroxide and aluminium foil into the substance lah, sample, and heat them. And then after that, the damp red litmus paper turns blue. Why is it like that? Because this one, when they heat the mixture of nitrate ions, sodium hydroxide and aluminium foil, actually ammonia gas is produced and H3 gas. And H3 is alkali. So it will turn the red litmus paper into blue color. So this is your first line, first point, second line, second point. Third line will be a third point. Okay, and then E. Calcium carbonate is widely used in agriculture. What is the use of calcium carbonate in agriculture? So this one, we'll use it as fertilizer lah. But we cannot straight away write this lah. So this one, why do we use it as a fertilizer? Because we want to use it to neutralize. So it neutralizes the acidic soil or lakes. So just like that, because calcium carbonate is a base. That's why when the soil or lake is acid because of acid rain, then we can use a base to neutralize it. So that's all for these two questions, and see you on Saturday.